Hello everyone. Hi. I'm your faculty for today, Saurabh. And I can see Yasin, Siddesh, Soni, Adarsh. A lot of people I know already actually, So, tell me, how are you? Good evening, Rutuja. Yes, you're from Pune, huh? Abhijit, hey, Ayush. Good evening everyone. Just tell me something. Am I clearly audible and visible to you first of all? Let's just make sure we're all on the same page. Hello, Path. Path is quite regular, yes. Rajshri, hello. Hey, good evening. Disha. Joshua. Nice. Ira. Alright. So, I'm clearly audible and visible to everyone, which means I think we are good to go. So, today, what to do? We have practiced reflection also, right? We have practiced refraction also. And I promised you that we'll come up with a session where we'll have a mixture of both of these concepts. And today is that session. Good evening, Sangeeta. Pranam, Master. Divya, good evening. Hey, Parul. Yes. So, I hope you have all practiced well, right? That fear of the important or the difficult concepts, refractive index, right? A lot of you told me that refractive index is something you are scared of. I think that fear is a little low now, right? I mean, we are not that scared, right? Good evening. Yes. So tell me, that fear is less now? I mean, do you believe me now, right? Which means the practice we are doing, it's working, right? The medicine we are taking, it's working. Means we have to take a little bit more. We have to practice a little bit more, and you know what? Your fear will be gone. That is our agenda for today. Today we'll practice questions together from reflection and refraction, and from next time you will say, this is easy, right? That's my goal for today, all right? So let's start. Papia says, let's start. Classes for, So two kind of questions. All right, Papia, just 1 second. I'll just make sure. First thing, a lot of you are asking for class 9th, which is very soon going to start. Don't you worry about that. I mean, you'll get this notification in some time. Don't you worry about this. Next thing is, the questions you asked, I'll talk about them. The questions you asked with me in the comment section in the last session, so don't worry, I'll talk to you about them. All right? Nice, Rutuja. It's easy for you. Let's start then. All right. So, the pen is also ready. Numericals on spherical mirrors and lenses. What we are doing is we are crushing the MCQs. All right. So let's start with the contents for today. Okay. Fine. All right. The laws of reflection. Let's go. Thank you. Laws of reflection. All right. Which we have done. Yes. Next is relation between focal length and radius of curvature. You know that. Next, the mirror formula. And one more confusion you always have is between mirror formula and lens formula. So just, I hope you have written this down and stick it on the wall. You are looking at it every day if you tend to forget them. Fine. So, mirror formula and magnification. Satyam, don't worry. Class 9th, it will come, and when I'm saying it will come, it means it will come. Don't worry. A lot of teachers have told you this. Be a little patient. It is coming very soon. I don't want to tell you, but yeah, very soon, in this month, you'll get this notification. Don't worry. Okay, next. Physics is not difficult. Quality is not good. Bhagirthi, just refresh once and make sure the net is working. I think for rest, it's quite clear, right? Thanks, Ayush, for me also. All right, guys, refractive index, lens formula, and magnification. All right, again, power of a lens. So this is everything we are going to use in today's session. So just be prepared with all these concepts in your head and we'll be using them. Fine. What do you say? No, Preeti, physics is not difficult. It's just more explorative. You have to see what's working around you, use a little bit of logic, a little bit of concept, and it's done. It's sorted. Richik, it's not clear. Richik, try to refresh once. I think it should not be a problem because from our end, what I know is it's working fine. All right. No, Siddesh. Come on, let's practice today now. your myth of telling that physics is difficult, it will break. Don't worry. Let's start. Come on. Let's start with the first question, guys. Come on. Sit tight, pen, notebook with you, solve it, give the answer. That's done, right? Let's do it. Shall we start? Okay, come on, come on, come on. Physics is not difficult, Sudesh. Come on, come on. Just stop spamming, man. Come on. It's not difficult. Let's do the question now, and you'll get to know. First question, come on. A ray of light is incident on the pole of a concave mirror, making an angle of 30 degrees with the principal axis. Find the angle of reflection. Do I need to solve this question for you? Tell me, come on. Yes, 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 give the answer. Nice, nice. C, 1B, okay, okay. What is given to you in the question? A ray of light is incident on the pole of a concave mirror. Fine, concave mirror is this one, right? This. Reflecting surface is curved inwards. That is the concave mirror, fine. Angle of 30 degrees with the principal axis. Alright, alright. Find the angle of reflection. Now just hold on. Did I tell you that laws of reflection are not valid in the case of curved mirror? Did you know this? I mean, no. Laws of reflection are valid. Wherever reflection is happening, it will have, right? So, when a ray of light falls on the pole of a concave mirror, it makes an angle of 30 degrees. What will happen to the reflected ray? It will, yes, it will follow the laws of reflection, which means the angle of reflection is equal to angle of incidence, no matter what. And yes, this will be the reflected ray at 30 degrees. C is 100% sure. Good, Padmali. Yes. And one more thing, just think about this. For this one ray, does it know is it falling on a concave mirror or a convex mirror or a plane mirror? No. That one ray doesn't know anything. That one ray is getting incident on one point. That one point is a plane mirror for everything, right? So always laws of reflection will follow. Doesn't matter what the surface is. If reflection is happening, laws of reflection will hold true. All right. This is one more question which can come in any exam, right? So this is one more thing we have discussed now. Yes, special case for ray diagrams. Yes, this is one more special ray. Nice, very good. See, very sure. Video is not working. Prerna, just refresh once. Refresh once, Prerna. So, all right. I think everyone got C. Fine. Okay. It feels good now when you get a correct answer. I know, it's an easy question. You will say that it's an easy question. Yes, I know it's an easy question. We'll be dealing with a mixture of questions, right? So that's why. Come on, next one. Question number 2. Is law of reflection always applicable for all questions? Hema is asking. Everywhere where reflection is happening, it will hold true. Fine. Nice. Okay. Come on, guys. Next question in front of us. Let's solve it again. Come on. Any problem? Nice, nice, Sarup. Oh, we are getting answers also. A concave mirror of radius of curvature 28 centimeter is used in a solar cooker. Okay, solar cooker. We use rays coming from the sun to heat food. This is the whole principle, fine. I mean, this is the crux at least. At which distance should the vessel be placed from the same mirror to get the food cooked? What do we want? Nice. I mean, seeing your answers, I don't even want to explain this question. I mean, all of you are giving the correct answer. Nice. Yes, Shyambabi, you are right. You are right. Nice, nice, nice. Okay. Main point here, main keyword was radius of curvature is 28 centimeter. All right. What is the crux? What is the hint we are looking for? We are looking for a concave mirror converges the reflected light rays to the focus of the mirror. Where is the sun? The sun is very, 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 very far, means infinity. Rays are coming from infinity. They will be parallel to principal axis. What do you want? You want these parallel rays to be focused at one point. What is that point? The point is focus. And what is the clue? Clue is radius of curvature is given to you, which means focus is half of that. Sun rays coming from infinity, parallel to principal axis, converging at a point, and that is where you will place your vessel. Relation between F and C is F equals C by 2. Nice. It's okay, Siddesh, don't worry. I mean, in this age and time, it happens, right? We have been working digitally for so long. Network error is a very common thing. Don't you worry about that. Yes, Rachita, nice. Nice and detailed answer. Good. 2f is the center, so focus is 2f by 2f, so 14 is the answer. You are right over there, Papi. Very good. So, to be precise, C is given 28, means half of that is f, that is 14 centimeter, and that is why the option we know is option B is the correct answer. Easy again, I understand, it's okay. It's all right, Sudesh, don't be sorry for this, it's okay. Come on, feeling good? Nice, nice. Parth is, everybody is getting good answer, right? It feels good when in the third session you see your students giving correct answers. It feels really good. Don't you worry. Alright, come on. Next question. Too easy. I agree, Ayush. Yes, too easy. I mean, the things you have learned till now, the way you have practiced till now, I really understand. It's too easy. Don't worry. We have good questions coming our way. The rear view mirror used in a car forms an erect image of the bus located at 3 meters from this mirror. Alright. Question is blurry, means network problem is there. So enjoy reading, refresh once, and make sure you have a good internet connection, right? So just try this, because yeah, blurry means same error. No, Siddesh, don't. You will do well, don't worry. Okay, we are getting answers like C and D. All right. Find the focal length of the mirror if the magnification produced by the mirror is 0.25. Now, before you jump to solve any question, I just want to ask you something. We have 4 options, right? Can you narrow down this? I mean, just by reading the statement of the question, which 2 options you can just rule out and why? That is my question. Come on. In physics, someone asked me, right, कि physics is difficult. Difficult nahi hai. It's not difficult. So what is the thing? You have to be logical. You have to be conceptual all at the same time. You read the question. Swaroop is saying B and D, alright, B and D, and why? Sathan is late. It's okay, Sathan, don't worry. You haven't missed anything. There were 2 easy questions. This is one more question where we are in between of something, and people are saying B and D. Siddesh is saying C and B, A and C. Are. Okay. Can someone tell me rear view mirror? Which mirror is used? Utkarsh is getting to a point over here. Innovation of a rear view is less than 1, so the image will. Nice, students. Yes. I can see Harimurli is also right. Very good. Yes, convex mirror. Because it has more field of view, it can cover more area. What do we want? We want a virtual image, we want an erect image, we want a convex mirror. Alright. So convex mirror is there, and focal length of convex mirror is positive. So yes, you were right over there. It is positive, which means negative is not possible. Alright then. With this knowledge, let's start the question. Located at 3 meters from this mirror. What is this? This is the object. What is the object? A bus. That bus is the object at u equals 3 meters. Alright. U will be minus 3 meters. Fine. On the left of the mirror. Fine. Focal length of the mirror you have to find, and what is given to you? Magnification is given to you. Alright. So let's quickly solve. I see all of you have got almost the correct answer, but still, if you are still doing, come on, let's do it together. You have to find the image distance, that is V. Alright, we have to find V. What is given to us? U is minus 3, I told you. Bus is the object at minus 3, left of the mirror, fine. Magnification is 0.25. It would have been, it's a convex mirror, means it will be diminished image, means it will be less than 1, that is also true. You have to find F, but to find F, you have to find V first, and what will you use? M equals minus V upon U. Don't be confused with the magnification in lens. That is V upon U. In mirror, it is minus V upon U. Yeah, fine. Okay. So, when you use this, just a second, I'll just solve it. It's minus of V upon U is minus 3. True? Alright. So, 0.25 equals V upon 3. So, V you will get 0.75 of meters. You got the V? Nice, Deepak. I'm really happy that it's very helpful to you. All right. So we got V, we have U, we have V, we have a formula which connects focal length with U and V. The formula is mirror formula, right? And what is that? That is 1 upon 1 upon f equals 1 upon v plus 1 upon u. Again, don't be confused with the length formula, 1 upon v minus 1 upon u. No, 1 upon v plus 1 upon u, right? So these confusions will occur, but with more practice, it will be removed. Don't you worry, right? So 1 upon f equals 1 upon v. What is v? V was 0.75 minus or plus 1 upon u. U is minus 3. Alright, you have to just solve it now. Simple mathematics. If you want to be more accurate with your mathematics, 0.75 can be written as 100 by 75. That is what? 4 by 3. So 4 by 3 minus 1 by 3. So this is what? 3 by 3 equals 1. What do you get? Focal length is 1. Which one? Plus 1. And we knew that. It will be plus 1, right? And that's why. The answer is option C. You see how the logic works, right? Alright, Ayush. Let's go to next question. Just confirming. Got the thing? You narrowed the 4 options into 2 options and then you chose the correct one. Alright, fine. Okay. Next question for you. Come on. It's okay, Santosh, don't worry. You're late, but you haven't missed a lot because we are still on the 4th question. But we are picking up pace now. Alright. So, a dentist uses a concave mirror of focal length 6 cm to see the magnified image of the tooth. If he places it at 2 centimeters from the tooth of the patient, then what is the position of the image of the tooth in relation to the mirror? Yassine says, please explain. You have some problem in that? See, Yassine, magnification was given to you as 0.25, right? U was given to you, right? So what can you do? Using magnification, you can find V, because m equals minus V by U. You will get the V, right? You will get the V, you have U, and you will use the mirror formula 1 upon f equals 1 upon V plus 1 upon U, and get the f. And f will be plus 1. Fine. This is the whole thing. I mean, if I want to summarize everything for you. Fine. Alright. Nice. Nice quote, Udita. Alright, guys. So, again, in this question, you can still rule out some options in this. I won't tell you which one. You tell me which one. Alright, okay, okay. Alright. Which case is this, if I want to be more precise over here? Focal length is 6, object is kept at 2. Object is kept between pole and focus, right? Pole and focus means the image will be, it will be magnified, virtual and erect, right? Fine. Alright, alright. And the mirror will be concave mirror given to you. Okay. So, position of image. Can the position of image be negative? No. The image is going to be virtual, means it will be positive. Again, out of 4, you now only have 2 options. Alright, let's start. Dentist mirror. You want to see virtual, magnified and erect image. Means focal length is minus 6. Because it was a concave mirror, minus 6. Fine. This was the mirror. Left of it, parallel rays coming like this, means f will be negative. F is minus 6. Fine. Object distance u is minus 2. Again, given to you. You have to find image distance v. How will you find it? Simple. You will use the formula. 1 upon f equals 1 upon v plus 1 upon u. How? 1 upon v is something you need to find. Plus 1 upon u is minus 2. 1 upon f is 1 upon minus 6. I'll just make some rearrangement. 1 upon 2 minus 1 upon 6 equals 1 upon v. Right? Right? What do you get? You get v equals plus 3 centimeters. And I can still see. No, Himaja. It's not a. It's 3. It's not plus 1.5, it's plus 3. And yes, most of you got the correct answer. Sonu has already given the complete answer in this. Nice. Alright, guys. Which means we are picking up really fast, we are picking up good, and we have learned a lot. Nice. I'm speaking English, Damu. Did I say in Hindi? No. We are talking English, come on. Next question, guys, come on. Observe the figure given below and find the refractive index of medium B with respect to medium A. We have 10 questions. Today we have a little less questions, don't worry. I don't want to take a lot of time because I understand you have got to that point where I want to take you, which means you are sorted. We just want to reiterate everything. Are we fine? So let's do that. Come on guys, this question, it's a very easy question of refraction, and I hope you can just give me the answer directly. Okay, A and B and A and B and B and A. All right. What I feared, you know, I feel some of you have done that. Okay. Watch the direction of the rays first of all. The direction is from where to where? We are so commonly, you know, we are so sure and so commonly seeing that one kind of ray that we don't even think. Look, what is the incidence angle over here? Angle of incidence is, all right, okay. Light is traveling from rarer to denser medium. Which one is the rarer medium? A or B? Oh, okay. All right now. Direction is A to B. I is 45 and R is 30. Yes, Rachita, that's correct. That's perfect actually. All right, all right. So, you have to find refractive index of medium B with respect to medium A. I told you one very easy way of applying a Snell's law. What was that? This is given to you, right? If you apply Snell's law conventionally, you might face problem, but one way is, let's say the refractive index of medium A is NA. Let's say refractive index of medium B is NB. Refractive index of that medium multiplied by sine of angle in that medium, which means I can write NA multiplied by sine of angle in medium A. Sine of 45 degrees. It will be equal to what? Refractive index of medium B multiplied by sine of angle in medium B, that is sine of 30 degrees. What do you want to find? You want to find refractive index of medium B with respect to medium A, which means NB upon NA is something that you need to find, which means sine of 45 degrees upon sine of 30 degrees equals NB upon NA. And this is your answer. Sine 45 is what? Come on, tell me. 1 by root 2. Sine 30 is what? 1 by 2, means you get answer as root 2. Simple. Nice. Got it? So, I am telling you it's alright. If you are very much proficient in using sine I upon sine R equals mu, that is fine. But you know what? I am more comfortable with this. Refractive index of one medium multiplied by sine of angle in that medium equals refractive index of second medium multiplied by sine of angle in that medium. And this whole thing, you can just make a rearrange. Fine. Got the idea? Ayush saying not clear. Ayush, apply Snell's law. No. What is there? Refractive index of medium B with respect to medium A means what? Refractive index of medium B upon refractive index of medium A. This is what? This is NBA means, or N mu of B A. Same thing. This is what you are supposed to find. How to find that? Apply Snell's law. Like this. Refractive index multiplied by sine equals refractive index multiplied by sine, and you will get the answer. Got it? Alright. Thank you, Ehar. Parth. So that's why I was saying A and B had a fight because we were doing mistake in applying the Snell's law. Nothing much. Simple mistake, common mistake, but we don't want to repeat it again. That's why we are discussing this question. Fine, and the answer is option A. Most of you gave the correct answer, but some of you were not able to give it. I hope it is clear. I hope tomorrow you won't do this mistake. Fine. Krishna, come on. Sine 30 multiplied by refractive index of B, sine 45 multiplied by refractive index of A, and equate them. What is the refractive index of B with respect to A? NB upon NA. Simple. This is the only concept, nothing much. Fine. Okay. Sachin, I have just explained again. Fine, alright. It's okay. It wasn't a very difficult question, it's just how to apply the Snell's law, nothing much. Guys, come on, next question. This one is, it looks lengthy, but it's not difficult. Believe me. Come on. Deepak got it? Sachin, if you have a problem in this, in the end, we can speak again. Don't worry. Because I think right now everyone got this properly. So, if you have a problem in this question, we can speak again. Alright, in the last question. Fine. Alright, guys. Come on. Next question. Nice, Deepak. No, Sathan. Tukka nahi marna hai. Alright. A light ray is made to pass through three unknown optical media P, Q and R. Guys, whenever you are dealing with a long question, be patient while reading it. Alright. Be patient. Try to mark the important words, because a long question first of all gives us a disappointment. Too long. How to read? How much to read? Don't worry. Just read it properly with patience. Fine. Okay, come on. A light ray is made to pass through three unknown optical media P, Q and R. Three media P, Q and R. Fine, light ray is passing through them. The refractive index of medium Q with respect to medium P is 1.2. Ting. This is a keyword. Why? Value is given to you 1.2. It is more than 1. Means what? Medium Q is denser than medium P. Alright. Okay. Nice, Chitra. You are way ahead of your standard now. Alright. Alright. AEK. Okay. Giving an answer. Nice. You think C, Fenera? It's okay. We have time. Cross check your answer. I'm explaining. Don't worry. So, first thing, medium Q with respect to medium P is 1.2. Means it is more than 1. Means it is a denser medium. Alright. Refractive index of medium R with respect to medium Q is 1.5. Okay. R with respect to Q is 1.5, more than 1 again. Again, it is a denser medium. Fine. If the speed of light in the densest medium out of P, Q and R, can you tell me which is the densest medium first of all? Nice. C, B, D, C, B. I know. When I get sweaty now, it shines like this. Hey, don't focus on my takla, man. Come on, just focus on me. Come on. Yes. P, Q and R. Which one is the densest medium? Can someone tell me? R. Yes, R. No, not Q, Rishi, not Q. It is R, na. P to Q is 1.2. Means Q is denser than P. Q to R is 1.5. Means R is denser than Q. Means R is the densest. The speed of light in the densest medium is 1.5 into 10 to the power of 8 meter per second. Find the speed of light in the rarest medium. Now, look, it was a long question, right? But the way you read it just now, I think you got what is the problem over here. R is the densest. If you found this much, most of the question is done. Fine. Nice. R. Correct. Let's begin. Let's visualize it. Medium P, medium Q. Medium P to Q, right? Medium P to Q is 1.2. Medium Q to R is what? 1.5, right? This is 1.5, alright. So, relative refractive index of a denser medium with respect to a rarer medium will be greater than 1. Denser to rarer, right? If it is more than 1, means it is a denser medium. If this much is clear, most of it is done. Why P and Q are equal? No, they are not equal. No. Q is denser than P. Why? I'll tell you. See, light ray coming from P to Q will bend towards the normal. Why? Because Q is denser than P. Light ray going from Q towards R will again bend towards normal. Why? Because R is denser than Q. See, I'm reiterating this concept again and again because it's a very important concept. And this is how the question will play with you again and again. So, if it is clear, a lot of questions will be clear. Yes. Nice. Alright. Only in maths, huh, Sathan? What about other subjects? Formula used is N21 equals what? N2 upon N1. This is what? A relative refractive index. This is what? An absolute refractive index, right? And this is equal to what? Velocity of light in medium 1 upon medium 2. Fine. If it is clear to you, NQP is 1.2. It is NQ upon NP. Fine. NRQ is 1.5. It is NR upon NQ. Fine. Alright. Okay. Now, what do you have to find? You have to find the speed of light in the rarest medium. And what is given to you? Speed of light in densest. We know now the densest is R. It is 1.5 into 10 to the power of 8. So, one way of doing it is find the refractive index of R with respect to P. And how to do that? Refractive index of R with respect to P will be NR upon NP. Look at these two equations, 1 and 2. How to solve them such that you get NR upon NP? See, NQ here is in numerator, here NQ is in denominator. Can you multiply both of them? Yes. What I'll do is NQ upon NP multiplied by NR upon NQ. And what do I get? I'm getting NR upon NP. So this is what? 1.2 multiplied by 1.5. It is coming out to be how much? 1.8. This is refractive index of R with respect to P. If you got this, I can write NRP equals velocity of light in P upon velocity of light in R, right? That's how we do it. Relative and absolute refractive index. See, relative is with respect to a medium, right? Any medium, it could be any medium, but absolute is with respect to vacuum or air. This is the difference. Fine. Priyanshu, yes, I just told you. Alright, so Vp by Vr. Vp is something you have to find, Vr is something that is given to you. So 1.8 multiplied by Vr is your answer, and that will be the answer. So what do you think? The answer would be how much? Come on, 1.8 multiplied by 1.5 into 10 to the power of 8, and the answer would be option B, right? Answer would be option. Is the most rare? No. Richik, it's not the most rare, it is the densest. Most rare is P in comparison to what? P, Q and R. You have three mediums, right? Forget there is something called as air. P, Q and R. In these three mediums, which was the densest? R. What was the rarest? P. Fine. Because Q was denser than P and R was denser than Q. That's why this is densest, this is rarest. Fine. Difficult to remember the formulae. You know what? It's not always about the formulas. It's about how you relate the dots. Denser to rarer away from normal, rarer to denser towards the normal, right? It will slow down. All these things, just think for a moment and realize what is happening. All these formulas is just numbers. Everything is the concept. Slowly you will get everything, and don't worry, with more practice this will be much more better for you. Shakir Shah says, please explain again. Alright. See guys, again, see, focus, I'm explaining to once again very quickly. This is P, this is Q, and this is R. Refractive index of P, right? Refractive index of P to Q. What was given to you? Medium Q with respect to medium P is 1.2. Means, do you agree Q is denser than P? NQ upon N P is given to you as 1.2. Fine. R with respect to Q, NR with respect to NQ is given to you as 1.5, right? This is also given to you. How is 1.5 most rarest? No. NQP, it should not be NP by NQ, it should be NQ by NP, right? This is the case. Yes. We can collaborate with Hindi. See, we are talking about language of physics. No, Rachita, it is NQ by NP. See, when you write NQP, it means NQ with respect to NP, means NQ by NP. Fine. So, this is given to you, and you have to relate speed with refractive index. So, when you got NR by NP, the velocity is velocity in P upon velocity in R. Getting this? Fine. And guys, if anyone has any problem in this concept, please stay in the end. I'm telling you again, don't worry. I'll explain it to you again, don't worry. Let's move on to next question. Kuldeep, I think I answered this. Relative refractive index is between two mediums which are not air, and absolute is refractive index of medium with respect to air or vacuum. Fine. This is the difference between absolute and relative refractive index. Fine. Okay. Nice. Come on guys. Question number 7. Observe the ray diagram and find the height of the image formed by the lens. Alright. Come on. Nice, Pushpa. Confusion clear. Alright. Kuldeep, I just answered this question. Fine. Okay, Ayush, है ना? Observe the ray diagram and find the height of the image formed by the lens. In the end, I'll give you one very small concept, and this refractive index versus velocity thing will be clear. Don't worry. And you know what? 35 minutes. Guys, come on, pick up the pace now. Observe the ray diagram and find the height of the image formed by the lens. This is an easy question, right? Thank you, thank you. All right, yes, we should use lens formula. Yes, true. You have to find height of the image formed by the lens. All right, height of object is given to you, u is given to you, and v is given to you, which means you know what to do, right? You know what to do. What to do? Yes, Santosh, you are right. Easy peasy, right? Huh? Okay, nice. Guys, come on. What we have u, right? We have u. We have v also. We have height of object also, but we don't know height of image. We have to use magnification formula in lens. And there is one very important thing. In mirror it is minus v by u. In lens it is v by u, right? M equals v by u. In lenses, I won't write it. I'll show it to you. I mean, in nice handwriting. Hi upon ho. Magnification is always what? How magnified the object is, which means height of image upon height of object equals v by u. Fine. So, if you use this, what will you happen? What will you get? Come on. Hi is something you need to find. Ho is given to you as 12 equals. Nice, Raghuvansh. Yes, it can't be negative as image is virtual. Where image is virtual? Did you notice the ray diagram? Ray diagram had an inverted image. Did you notice? Right. Hi upon 12 equals v is plus 50 upon u is minus 30. Right. 3 is 4. So hi you are getting as minus 20 centimeters. There is a negative, means the image is inverted. Yes, real and inverted. Ram and Sham, you are right. So, and again, image is not virtual, no? Just see, they are actually meeting on other side of the lens, means it is a real image. It is below principal axis. It is supposed to be negative. I mean, looking at just this figure, you can say A is not possible and C is not possible. Why? It cannot be positive. Height of image can never be positive. Why? If it is below principal axis, it has to be negative. But which negative? Minus 15, minus 20, that you have to solve. Got this? Yes, Ehar, you are right. Thank you, physics world. Nice. Got the answer as D? Okay. All right, guys, come on. Next, question number 8. And this is a little difficult kind of question. Again, there is a lot of text over there and you see this meter going red. Matlab difficult hai. Okay? Don't worry, Sachin. We'll deal with that. Yes, for sure. Hindi, English, I'm telling you, see, it's about the language of physics. It's about formulas and concepts we are dealing. Hindi, English में क्या रखा है बताओ? Question समझ में आया? Question clear हुआ? इतना काफी है. English में बोला या हिंदी में बोला, it doesn't matter. All right, fine. ठीक है. Next question. Minus v by u is for mirrors. For lenses, it is v by u. Kuldeep, ठीक है? All right, come on. Alia is trying to see an ant of length 2 millimeter up close. Similar kind of question you have tried before also. I understand this. Maybe C. Okay. Just cross check your answer and answer again. I'm not saying it is wrong or right. I don't know yet. I mean, I'll solve it, but I don't know yet. If you are doubtful, means there is room for improvement. All right. Okay. V by u for lenses. ठीक है. Alia is trying to see an ant of length 2 millimeter up close. She is using a magnifying lens of focal length 10 centimeter. All right. Length of ant is 2 millimeter. She is using a magnifying lens of focal length 10 centimeter. Magnifying lens कौन सा होता है? Come on, tell me. Which lens do we use as a magnifying lens? Concave or convex? Nice. Sorry, Krishna, I think I missed your question. Yes, not concave, convex. Yes, right. Abhijit is right. Fenil, Kamal, nice. Sanstita, correct. Correct. Convex lens होता है, right? Focal length positive होगा, right? If the aunt is placed perpendicular to principal axis of the lens at 8 centimeter away from the lens, do you again notice something? Focal length is 10, aunt is placed 8 centimeter away. Matlab, it is between optical center and focus. It is going to be virtual, erect and magnified image, right? That case of convex lens. Find out the length of its image. Shambhavi is saying D. Okay, so let's start. Come on. 2 millimeter, 10 centimeter and 8 centimeter. U is given to you, F is given to you, and height of object is given to you, right? This is all the information you have. Fine. U, H, O and F. First you have to find image distance V, right? Right? Okay. And what will you? You'll use the lens formula 1 upon V minus 1 upon U. Yes, Anoop. That case between F and O. You are right over there. Come on, guys. F is positive or negative? Positive. Why? Convex lens. That's why. Plus 10 equals 1 upon V, I don't know, minus 1 upon U, U is minus of 8. So 1 upon 10 equals 1 upon V plus 1 upon 8. Make some rearrangement. It will be 1 upon 10 minus 1 upon 8 equals 1 upon V. Solve it, right? Come on, come on. Tricky one, huh? Fenil, you were saying maybe C. It's not tricky. Come on, come on. That's the beauty of questions. You feel challenged, right? If someone is there to challenge you in each and every question, you feel good. The more challenges you face, the more confidence you get. So 1 upon 10 minus 1 upon 8. Come on. V will be equal to minus 40, right? You will get V as minus 40. Fine. Now you have to find height of image. You got V, right? You got V, you have U. Now you can use the magnification formula. This one, height of image upon height of object. Ananya, confused? Why? Don't worry, Babaya. We'll get more case study questions. We have just started, man. Come on. Today I wanted to make sure that these concepts of reflection, refraction are fully clear to you, but we'll have assertion reason and case study questions more. Don't worry. Yes. What is the confusion? U was given to you, F was given to you, and height of object was given to you, height of image was asked. You have only one way to find that, right? You have one formula is magnification. Height of image upon height of object equals V upon U. If you want to use this formula, you also have to find V, and to find V, you have to use the lens formula. Itna hi to concept hai. What else is there? So use this. Come on. Height of image you have to find. Height of object is 2 millimeters, right? Is equal to V is minus 40. U is minus of 8. Fine. You get as, yes, come on. HI equals 10 millimeter. Yes, minus 40. V is minus 40, and that's why you got 10 millimeter. Now I'll ask you one more thing again. Nice, Deepak. You are confident now. Now one more thing I just want to ask you. Once you read this question carefully, you understood that object is between focus and optical center, means image is going to be virtual, erect and magnified, right? If it is going to be virtual and erect, can height of image be negative then? No, it won't, right? It won't. And that's why it could only be plus. Why it is 10? Use the formula. HI upon HO equals V by U. So V was minus of 40, U was minus of 8, height of object was 2 millimeter. Use this. Yes, never. That's why in these questions now there is a very good room to rule out two options very nicely. So be prepared. These kind of things will happen. You have to use logic also, not just jump onto formulas. Yes, good. Okay, just a second, Abhijit. If V is negative, this means image formed is virtual. Yes, but you told that image formed, no. V is what? V is what? The position of image. Fine. In a convex lens, in a magnifying lens, there is only one possibility when V could be negative. In rest of the cases, V will be on the other side of the lens, right? It will be positive. Fine. But there is only one case between F and O that V could be negative. That is virtual, erect and magnified. That's why. Fine. Nice. Alright guys, come on. Ninth. A beam of light passing parallel to the principal axis of a diverging lens appears to come from a point which is located at a distance of 20 centimeters from its optical center. Come on. Nice. Dr. Strange is also here. Hello, doctor. Come on, guys. A beam of light passing parallel to the principal axis of a diverging lens. Once again, diverging lens. Concept alert. Diverging lens. Which one? Convex or concave? Come on. While you are reading a question, these kinds of concept alerts come in your mind. Diverging lens. Okay. Concave lens. All right. Appears to come from a point which is located at a distance of 20 centimeters from its optical center. Find the power of the lens. What is given to you? In this language, question has given you an information. One very important point. What is this point? What is 20 centimeter? Nice. PDF wise, Ayush, you know what? I don't think as such PDF wise, but you know what? All these sessions are there on the channel, right? You can just have a look, because you know how many questions do we cover? 10 or 15. You can just jump onto questions. Which question did I miss? And the way we explain it, how much time we spend on one question, it's quite enough. So I don't think there is as such a PDF required. But you know what? Everything is there in the channel. Don't worry. Fine. Yes. Oh, you guys are given the answer also. All right. So what is given to you? A diverging lens. Diverging means parallel rays to the principal axis, they will diverge after getting refracted. Means if you look from here, what do you get? It appears to you that these rays are coming from a point. That point is what? Focus, right? That is focus. So what is given to you? 20 centimeter. It is a diverging lens. Focal length is 20 centimeter. It will be minus y left. So F is negative. This is the important thing. Nice. Focal length is minus 20. Now there is room for only one mistake. What is that? You can write 1 upon minus 20, but you know what? You won't do it because you understand that focal length should be in meters. While you are using the formula for power, it should be in meters. That is another important concept. It is 1 upon F in meters. Minus 20 means minus of 0.2. So this is minus 5D. And yes, you are right. Option B is the correct answer. Nice, Papia. Rituja, nice. Alicia, very good. Oh, congrats, Krishna. Priyanshu, I just answered this to Ayush also. Every question is there, right? Don't worry. These questions, we are creating them for you to practice. This is how we are practicing. If you missed any question, the video will always be there, right? Come on, guys. Question number 10. An object is placed in front of a lens of power specification plus 4D. Find the position of the object in relation to the lens such that an erect image is formed at 50 centimeters, minus 5 diopters. Very good. Come on, guys. Come on. Final question. Object is placed in front of a lens of power plus 4d. Plus 4d. There is a lot of information given to you in this number. Plus 4d. You have 2 questions, all right. Okay. You have 3 questions. All right. Diopter is the unit of power of a lens. Fine. And it is 1 upon focal length in meters, right? Converging length and focal length. For converging length, you can just say focal length would be positive. Why? Because light rays will come parallelly and they will actually meet on the other side of the lens. It will be positive. How much depends on the thickness and many other things. Yeah, Udita, you can ask. Alright guys, come on, rest of you, solve this question. I am getting B, C, C also. Yes, you are right over there. Convex lens, since its power is positive, that's why I told you. Plus 4D means positive. Positive means focal length is also positive, right? So, what do you think? You have got power as plus 4D. It is a convex lens. We understand this. Find the position. Assertion reason. I know, guys. Come on. I know. You want case study and assertion reason. I promise. Nice. Come on. Yes. In relation to the lens, find the position of the object in relation to the lens such that an erect image is formed at 50 centimeters from the lens. What is given to you? This is the position of what? Don't worry, Sachin, I told you. Question number 5 will deal. Yes, come on guys. V is the given to you, right? V is given to you. P is plus 4D. So can't you find focal length? Yes, you can find 1 upon 4, that is 0.25 in meters, means it is 25 centimeters. This is the focal length. You have F now, you have V, can't you find U? You can, right? Focal length F is given to you now, plus 25 centimeters, right? You just have to find object distance, that is U. What formula you will use? The lens formula, right? So 1 upon 25 equals 1 upon V is minus of 50, right? Minus of 1 upon U. Make some rearrangement. 1 upon U equals 1 upon 25 minus 1 upon 50. What do you think? 50, 2 minus 1, it is 1 upon 50, right? Oh, no, sorry. I made some mistake. When you bring 1 upon 25, it will also be negative. So this is what? This is 50 minus of 2 minus of 1 equals minus of 3 by 50. Sorry. You got as minus 16.67 centimeters. This is the U. Nice, Piyush. Parul, yes, I have taken your name. Alright. Next class, don't worry, it's a surprise for you, but it will be important. Don't worry. And I can promise you one more thing. In the next class, we'll have more and more assertion, reason and case study questions. Yes. So, we have got the answer, option B. Fine. Alright. Nice. Okay. So, guys, we have got you covered. Don't worry about that. Brief note on Snell's law. Yes. Alright. Alright. So, when I say we got you covered, now is the time I can tell you. When you say Snell's law, see, how do you remember it? This is a ray going like this. You say it is bending, right? This is the most common way you know about refraction. But how to write the Snell's law? This is I, this is R. You say mu equals sine of I upon sine of R. Guys, all of you who had confusion regarding velocity and Snell's law, just focus over here. On refractive index, I'll keep this in mind. Don't worry. Guys, come on. All concave lenses, F is always be negative. Yes. See, and I see that one more question was there in the last session, that can convex lens be divergent? See, guys, whenever we are saying now focus or focal length, we start with the parallel rays, right? The rays which are parallel to principal axis. When these rays fall on a convex lens, they converge, right? And when these rays fall on a concave lens, they diverge, which means on that side, it is only possible for a convex lens to get these rays meet, right? But concave cannot. That's why concave has negative, convex has positive. Fine, right? Yes, Sachin, don't worry, don't worry. Scattering of light, atmospheric refraction, yes. This is in human eye, don't worry. We have a whole session planned for that. Guys, focus over here. Sin I upon sin R. This is how you write, but you know what you are doing. This is mu of second medium with respect to first medium, which means this is what? Mu 2 upon mu 1 equals sin I upon sin R. If you make a rearrangement again, this will be what? Mu 2 multiplied by sin R equals mu 1 multiplied by sin I. Now tell me, isn't this the same thing which I was telling you before? Isn't this the same thing? Yes, right? Sin I multiplied by mu 1, sin R multiplied by mu 2. Simple, Snell's law. Yes. All right. Yes, guys. So, you were asking about next session, optical phenomena in nature, which means you were talking about scattering, we'll deal with that. Atmospheric refraction, we'll deal with that, don't worry. Yes, yes, paraxial rays. All right, and one more thing, a free trial class for everyone. You know that. I mean, if you want, you can try. Okay, so this is all for today's session. And Sachin, don't worry, I'm coming back to the fifth question. So yes, question number 5th. I'll do this very quickly now. This question, right? I told you. Thank you, Dita. Same to you. Good day. Thank you everyone. Sachin, just stay for a second. I'll tell you this again. This is 30, this is 45. First of all, notice where the ray is going. Ray is going from A to B. Even if you don't want to learn about this, you have asked medium B with respect to medium A, right? When you write medium B with respect to medium A, you write it as NBA or NB upon NA, right? This is what you are trying to find. Fine. Sachin, are you there? Right? This is NB upon NA, and when you apply Snell's law, you write this is NB, this is NA, so NA multiplied by sin 45 equals NB multiplied by sin 30. If you do this, you will rearrange it and you will get sin of 45 upon sin of 30, and that's how you will get root 2. Got this? Guys, all these questions I'm not very sure of. All right? Yes. Okay, everyone. So this is everything we have dealt with in today's session, and you know what is going to happen in the next session, which means you have to come prepared, and we'll solve a good amount of questions. We'll solve assertion, reason, case study questions. And yes, we have got you covered. Don't worry about that. Fine. All right. So I'm Saurabh signing off, and I'll see you again in the next session.